Yes, thank you. Thanks for the introduction. And thanks for having me here. Thanks all for joining for this talk. The title is Fantastic Virtual Threads and How to Monitor Them. So what we're going to do is we're going to look at virtual threads, how do they work, and we can also look at some tools which help us to monitor them. Yeah, my name is Balkrishna Rawool. I work for ING Bank. And before we get started with this talk or with the details of virtual threads, I want to actually show you an application that I have built using Spring Boot, and that application also uses virtual threads. And there is actually a problem with it. So what we're going to do is we're going to look at an application which has a problem, and then we're going to look at what virtual threads are. Then we're going to look at some monitoring tools, how to use them, and in the end, we are going to try to fix that problem using the things that we have discussed in this talk. So let me first go to this app and then start the application. So it's a Spring Boot app. I go to here and then let me start the app. So now the app is starting. And this is a Spring Boot app, which also has HTML, JavaScript frontend using Bootstrap. So let's see how that looks. And it looks like this. Let me refresh this page to see that we are actually able to see some data on the screen. So what this app does is it shows some financial information about some companies which help us to understand these companies a bit better. And I have a list of companies here, Microsoft, Apple, Amazon, Google, Facebook, Netflix, all of these. And then it shows some financial information about them. And as I switch this company, it fetches different information from these different companies. But sometimes you see there is an error here, right? And this is actually the problem that I'm talking about. And this problem is pretty random. So if I switch to something else, then I get the values properly, but sometimes it has this error. And the interesting thing about this application is that the backend is built with Spring Boot. It exposes different endpoints. In fact, there is one endpoint for each of these values. And each of these endpoints actually create a virtual thread to process the request that they receive. So there is some problem with one of these virtual threads or these endpoints which is using virtual threads, and our aim is here to find out what the problem is. Now let me just quickly switch to other values. So now you see this value is coming, but yeah, sometimes it fails. Okay, so now let's get back to our talk presentation, and let's start with the first part of this talk, and that is fantastic virtual threads. So in this part, we're gonna understand a little bit more about virtual threads. So virtual threads are part of Project Loom. So they are one of the features in this important project called Project Loom. And the aim of Project Loom is to provide high throughput concurrency, and virtual threads really help us to achieve that. This feature is now a stable or a final feature since Java 21, which was released in September this year. And to understand virtual threads, we need to first start with platform threads, or otherwise known as threads in Java. And they are present in Java for a really long time. And platform threads are actually a thin wrapper over operating system threads. What does that mean? It means that when JVM has to create a new instance of a platform thread, it actually asks operating system to create a new thread. And only when an OS thread can be created, a new instance of platform thread is created in the JVM. Creating an operating system thread is a resource-intensive task. It requires some memory, it takes some time, and only when that has happened, we are able to have a new platform thread. So you can imagine creating a platform thread is also a resource-intensive task. It offers limited scalability when using thread per request model. What does it mean? Now let's first understand what is thread per request model. So if your application is creating a new thread to process a new incoming request, then that is known as thread per request model. And we say that platform threads offer limited scalability when using thread per request model. And that is because if your application is working in thread per request model, then the maximum number of requests you can handle or you can support would depend on the maximum number of platform threads or maximum number of threads you can have, right? And if those are platform threads that you are using to fulfill those requests, then it would depend on the maximum number of operating system threads that you can have, right? And creating operating system thread is a resource intensive task. So you can have only so many number of operating system threads in your application. Therefore, you can have so many number of platform threads in your application. And that's why we say that the scalability offered by platform threads is limited. There is need for pooling. As we said, creating a platform thread is a resource intensive task. Therefore, you don't want to create platform threads too often, or when you are done with a platform thread, you don't want to throw it away. What you do is you pool them so that next time when you need a platform thread, you can get it from the pool. Therefore, platform threads need pooling. Virtual threads, on the other hand, are lightweight user threads. Lightweight meaning they require significantly less amount of memory than platform threads. And because of that, you can have a huge number of virtual threads. And that's why they are highly scalable. You can have thousands or even millions of virtual threads, and that makes your applications highly scalable. Also, there is no need for pooling. So creating a virtual thread is a pretty cheap operation. So you create virtual threads whenever you need them, and when you don't need them, you just throw them away. There is no need to pool. In fact, pooling virtual threads is a sort of anti-pattern. Don't do it. What we see here in this picture is that we see platform threads. And as we saw in the previous slide, for every platform thread, there is also an operating system thread. So the mapping between platform thread and operating system threads is one-on-one or one-to-one. And we see high number of virtual threads. Some of them are also mapped to platform threads. Why is that? That is because a virtual thread in its own cannot execute anything. It really requires a platform thread to execute something, and therefore a virtual thread is mapped to a platform thread when it has to execute something. But we see virtual threads pretty high in number. So how is that mapping done? And for that, we have something known as virtual thread scheduler. Now, what this scheduler does is it ensures that a virtual thread gets a platform thread when it needs it. In fact, that process is known as mounting. So a virtual thread is mounted onto a platform thread when it has to execute something. And a virtual thread is unmounted from the platform thread when it does not require any execution. For example, it is, let's say, waiting for a network uh, resource to be available, or waiting for a database to return some results, or waiting for file IO. So in all these instances, a virtual thread is just waiting. It does not require CPU. It does not require platform thread to execute anything. Therefore, it is unmounted from the platform thread. Now, in this whole context, platform threads are carrying virtual threads. Therefore, they are also known as carrier threads. Okay, so we have seen a few things about virtual threads. We have seen how they get mounted and mounted, but let's see them in action. Let's create some virtual threads, and then it will be clear how does that work. So let me head over to IntelliJ and then create some threads. So I have. I hope the font is big enough and you are able to read the code easily. Okay, I have increased the font size, so it should be easily readable. Let me create a new platform thread, and the way to do that is a new thread, and then I can pass a runnable to it. And in this case, I'm just gonna pass. I'm just gonna execute a statement which prints the current thread. And then I do thread.start. So that starts a new thread. And you might have seen this kind of examples a lot, or you probably are already familiar with this. So if I now execute this method, I will see a new platform thread being created. And in order to execute this, I have created a JUnit test, which is actually not really a unit test. It just executes this method. So I'm just going to run this platform thread. So if I run this, I should see a new platform thread being created. And yes, I have a platform thread created here. With Project Loom, there's actually a new API to create a new platform thread. And the way to do that is thread.outPlatform dot start. And this creates a new platform thread. So if I run this, I should see the same thing, a new platform thread being created. Okay, so if this is the way to create a platform thread, is there a similar way to create a virtual thread? In fact, there is. So in here, instead of saying a platform, we can just say of virtual and we get a virtual thread. So if I run this, I should see a virtual thread. So again, for this, I have a JUnit test. So let me run that. If I run that, I see a new virtual thread being created. In fact, there is a shorthand method to create a virtual thread. So I could simply do thread.start virtual thread, and this should give me the same thing, a new virtual thread. I can create a new thread, a new virtual thread by using an executor service. So let me do that. I use a try with resources. I create a new executor instance, and this will be executors dot new virtual thread per task executor. So what this does is it gives us an executor service which creates a new virtual thread every time you request a new thread. So there is no, although this is an executor service, there is no thread pool behind it. And also we are using try with resources. So let me create a new virtual thread, and we do that by using executor.submit, and we submit a runnable to it. And again, we're going to print the current thread. So if I do this, I will have a new virtual thread. And the idea of using try with resources is that all the threads that I will create by using this executor, they will all, it will be ensured that they are finished before before exiting this try block. So if I do this now, I should see similarly a new virtual thread being created. So there we have it. We have a new virtual thread. And if you see here, at least in the two-string representation of the virtual thread, we see a bunch of things. So first is this part, which is the ID of the virtual thread. And also behind this at, we see this, which looks like a platform thread. And in fact, it is a platform thread. So what we see here is that this virtual thread is at that time of executing the statement was mounted onto this platform thread. So if we have a bunch of new virtual threads, let's see how they behave. So we will see a bunch of virtual threads being created, each with a different or unique ID, and they are running on these platform threads. And also we see a bunch of them are running on the same platform thread. What does this mean? So this means that this virtual thread, when it was finished, it was unmounted from this platform thread, and a new virtual thread was mounted onto it. So this way, a lot of these virtual threads were mounted and unmounted from the same platform thread. And that's how large number of virtual threads are supported by a few platform threads. Okay, so we have seen a few things about virtual threads. How do they work? How do you create them? How do you interact with them? But there's one thing that we need to be aware of when using virtual threads, and that is pinning. So pinning is when a virtual thread cannot be unmounted from the carrier thread. And as you can imagine, this is not something that you desire from a platform thread, from a virtual thread. In fact, you don't want them to be pinned for a really long amount of time, because if a virtual thread is pinned to the platform thread, the advantages of having a virtual thread are not there. It behaves just like a platform thread, and therefore there is no benefit of using a virtual thread. So when does it happen? It happens when a virtual thread is executing a synchronized code block or a synchronized method, or it is executing a native call. And how do you deal with it? So if it is a synchronized code block or synchronized method, and it happens for a really small amount of time. So if your synchronized code is getting executed really quickly, it is not a problem. So pinning is only a problem if you are doing long running or blocking operations inside your synchronized code block, right? If it is long running, then the virtual thread is pinned for a really long amount of time. If it happens for really small amount of time, your application won't notice it and you would not have any problem. But if you do have a problem, then you can actually replace the synchronized code block with reentrant lock, and that will ensure that your virtual thread does not get pinned to the platform thread. Also, there is work going on. So in future, the synchronized code block or synchronized method would not pin the virtual thread to the platform thread. So then you would be free to use the synchronized code block or synchronized method. Okay, so that is the end of part one, fantastic virtual threads. And now part two, how to monitor them. Now in this part, we're going to look at a few monitoring tools. In fact, few tools which help us to monitor Java applications. And they are these. So JFR, JDK Flight Recorder, and then we have JMC, JDK Mission Control, Visual VM, and JCMD or JCommand. Uh, why have I selected these tools? It's because so a few of these tools, specifically JFR and JCommand, they have some extra features which make them interesting for using them for applications which use virtual threads. And we're going to look at what those features are. And JMC and Visual VM provide visual interface to analyze data created by these utilities or these tools. So that's why I've selected these four tools. So let's get started with the first tool, and that is JCMD or JCommand. So what does JCommand do? It helps us send diagnostic commands to the JVM or to the Java application, and it supports a lot of commands, and we'll see that in a bit. And some of them are related to JFR, some of them are related to garbage collection, and some are in general giving information about JVM. One thing is that JCommand must be used on the same machine where the JVM is running. And the way to use it is, you just use a command called JCMD and then pass process ID or main class, and then your actual command with some options. So let's see what are the possible commands that we can send by using JCommand. We already have an application running, our Spring Boot application that is running. So what we are going to do is we are going to look at what are the options that are available to us, or what are the commands that are available to us via JCommand. So let's first get the process ID of the application that is running. And it is this 97977. And let's see what does JCommand make us possible. So if I do JCommand process ID help, then I get to see all the commands that I can send to that application. And you see there are a bunch of them. Some related to compiler, some for garbage collection, some JFR, management agent, JVMTI as well, threads, and general VM commands. So let's use vm.uptime. And that will tell us how long have this application been running. So it says that it has been running for 996 seconds. That's probably since the time that we just started in this talk. Now let's just see the system properties for this application. And if I run this, I get a whole list of system properties. Also, there are some other interesting commands. There is this gc.class histogram, and that gives us all different classes and how many objects it has, how much memory it is using. And this is actually pretty big list. Also, we can get a thread dump from by using JCommand. So we can just do we can get a heap dump actually. So let's just first get that heap dump to a heap dump file. And okay, so we now have heap dump in this file, heap dump.hprof. It's here. And if I try to open it, it is actually binary file. So we are not able to see it here in the text editor. But what we're going to do is later when we look at JMC, JDK Mission Control, we will be able to open this file in JMC and then see the contents of it. It should show what is present in the heap at this moment in time. So that's a few things about JCommand. But as you saw, there is a whole list of commands that you can run against the JVM or Java application, and then you can get a lot of important information about the Java application. Also, there is one thing that makes it interesting when using an application with virtual threads, and that is that it now supports thread dump in a JSON format. So let's see how that works, and also see why is it important or why is it interesting for applications with virtual threads. So let's run this command to get the thread dump in JSON format. G command, process ID, and then we're gonna do thread dot dump to file, and then we pass in an argument format equals JSON, and then just give the file name. So thread dump.json. So it's gonna be JSON, which will be we will be able to open it in text editor, and then we can see what is inside the file. So this file has, among other things, information about threads, obviously, and it groups these threads into thread containers. So we have a bunch of thread containers here. And then each thread container also gives us information about how many threads there are. So for example, this root thread container has now 10 threads. And yeah, then you see the stack traces of each of these threads. Let me see if there are any virtual threads present here. So if I search for virtual thread, yeah, I just see virtual thread unparker. This is not really a virtual thread. This is in fact a normal platform thread. So we see it here, thread.run. So there is no virtual thread present at this moment in time. But let's just do something so that we can actually get a thread dump with virtual threads and then see how does it look in the JSON format. And for that, what I'm going to do is I'm going to use an endpoint that I've created. There's this VT controller, which provides two endpoints. One is called thread info, and the other is called thread info delayed. So what thread info does is it basically returns the current thread in its string representation. So let's call this endpoint and then see what does it give. So if oh yeah, and before I do this, I want to show you something interesting. And this is a Spring Boot application. It uses Spring Boot 3.2. And there we have an interesting property, spring.threads.virtual.enabled. And if we set this to true, Spring Boot application starts using virtual thread executor. What does that mean is it creates virtual threads. So if I now call this endpoint, it will create a new virtual thread and it will start processing that request using that virtual thread. So if I do current thread, I should be able to see a virtual thread. So let me call this endpoint and see what we get back. We get back a virtual thread. So with this ID. Now I have another endpoint, which is virtual thread delayed, and it actually does the same thing. It returns the current thread, but before that, it puts a delay of 10 seconds. Now, the reason why I have done that is when I call this endpoint, I will be able to get the virtual thread with its toString representation, but it will allow me to do some things so it is going to take 10 seconds before it returns this. And during that time, I'm going to get the thread dump so I can see a virtual thread in the thread dump. So let me set the command ready. So I'm going to use the same command to get the thread dump. But in this case, I'm just going to use this flag override to override the current file. And let me run this thread info delayed. And while I'm using that, it's going to take 10 seconds. And meanwhile, I get this thread dump. So I have the thread dump now. And in a few seconds, I will also have the virtual thread created here. So we see the virtual thread with ID 141 was created. And if I open the thread dump now, let me open it in maximized format. And now if I search for virtual threads, I see a few more hits. So again, you see this is a virtual thread because this is started using virtual thread.run. And we see that it is ID 141. So that's the virtual thread that actually processed our request. And it is now at a state which is sleeping. So virtual thread dot sleep, and it was started from virtual thread or thread info delayed method. So exactly this was the thread that was processing our request, and at this point it was sleeping when we got this thread dump. So that's how you can get the thread dump in JSON format. And why does the JSON format make it interesting for virtual threads? So if you're using virtual threads, or more specifically, if you're using structured concurrency, you can have virtual threads started in different scopes. In fact, in nested scopes, you have a tree of virtual threads, and seeing them in JSON format makes it really easy to navigate and then see which threads are. And also with virtual threads, when you create high number of threads, JSON provides a nice navigation way to get to the virtual thread that you're interested in. So that's a bit about JCommand. Now let's move on to the next tool, and that is JFR, or JDK Flight Recorder. JFR is an event-based tracing framework built into the Java runtime, and it gathers low-level information about how JVM or Java application is behaving. It maintains low overhead, and with this data is continuously recorded and optionally returned to disk. So basically, because it provides low overhead, you can also use it in production along with your application, and it records data continuously. And whenever you need it, you can also write it to the disk. And it records data about Java events because it is an event-based tracing framework, and there are different kinds of events that it records. And some of them are duration events, instant events, sample events, and custom events. So duration events are the ones which have start and end time. Instant events are that happens at particular instant in time. Sample events are events that are happening periodically. So if you want your garbage collection to be run every few minutes or seconds, then those are called sample events, and you can also monitor those, and you can also create your own custom events. In order to support virtual threads, JFR has now 4 new events. Actually, it supports more than 180 events. And with virtual threads, we have 4 new events: thread start, thread end, thread pinned, and thread submit failed. Thread start and thread end, they are not enabled by default, so you have to do something to enable them. Thread pinned and thread submit failed, they are enabled by default. So how can we start a JFR? You can start it while starting your application by passing VM arguments, or by using JCommand, or via JMC. So we're gonna see that by using via JCommand, and we'll also later see it how we can use it with JMC. Also, we said that it is continuously running, and you can dump it to a file when you need it, but you can also stream these events, since this JP event streaming for JFR events is also enabled. Okay, let's see JFR in action, and let's start it using a JCommand. We have an application running, and we also know the process ID, and so the way to do that is with JCommand process ID. Oh yeah, it's here. So JCommand and this process ID, and then I'm gonna use a command called jfr.start. And we said that these events, virtual thread start and end, are not enabled by default. So to enable them, we use JFR configuration file. It is an XML file where we say what events are enabled and what not. So what I'm doing here is for start and end, I'm changing this enable to true. This is false by default. And then I set that as my configuration file. So we say settings equals template vt.jfc. So now JCommand, so JFR is now started, and it is creating or it is recording these events. So what I want to do is I want to run the thread info command a bunch of times, and then see that if those events are recorded in the JFR. So the next thing to do is I'm going to do jfr.dump, and then pass a file name. Let's call it recording.jfr. And this will dump the events to a JFR recording file, which is this recording.jfr. Again, this is a binary file. Let me just stop the recording first. I mean, it's not big overhead, but let's just stop it. So this is a binary file, so we won't be able to see it in text, but there are a couple of ways to see this file. One is to use the JFR utility that is present in JDK, and the other is to use JMC. So let's first use the JFR utility, and I'm gonna go to Java home/bin/JFR. And there are actually a bunch of things that you can do with this command. So if I do help, I get all sorts of things that I can do with it. One of the things is to print the recording. And this basically shows it in human readable form. But again, it's a big file, so a lot of things are there. Let's just get a summary of it. And what summary does is it gives a summary of what all events that were created. Again, it's the big list, so I'm just gonna grep it because we are only interested in virtual thread events. So let me just do this, and this gives me this info about how many virtual threads were started and ended. So I see 9 virtual threads were. So maybe we executed the command enough amount of times to create 9 virtual threads. So this is how you can get information about virtual threads by using JFR. But we will actually, this file has a lot more information. We can open it in JMC, and then we will see what else is there. Yeah, moving on, JMC. So JMC provides a control panel for managing, monitoring, and troubleshooting JVM applications. It gives a lot of information about CPU usage, memory usage, threads, MBs, and even more, and we will see that in a bit. You can also run your JCommand commands from JMC. It provides different views, ambient server, JDK flight recorder, and it also has abilities to add some plugins. So let's quickly take a look at JMC. Let me open JMC. Oops. And yeah, so what we will see is that JMC provides a nice visual user interface to monitor our Java applications. So what we see is there's a JVM browser, which actually lists all the applications that are running on this machine. And we see our application, monitor virtual threads application is also listed here. And let's interact with it. So it provides a MBean server, which basically connects to the MBeans using JMX, and it gives a lot of information about the processor, memory, uh, and yeah, we see the usage of CPU and memory here. But there's a lot more. So you can also browse through all these MBeans. We can get system information. We can also get information about the memory, threads, of course. And we see here diagnostic commands. So this is basically a way to run our JCommand commands. So we could let's just run pm.uptime, and this was the command that we ran using command prompt. But we could also uh, yeah, run it here. So it shows all of these things. We can even run garbage collection. And then we should be able to see that memory has been reclaimed. So yeah, so basically this provides a nice interface to interact with it. In fact, you can also run the JFR um, commands from here. But if you just want to use JFR, there's another nice utility here. So what we will do later on is we'll create a new JFR recording by using JMC. But before that, remember that we created this heap dump, right? And it was in binary, and we said we will open it in JMC to see its content. So let's open that now. Let's open the heap dump file. And if I open it, it gives me a view of the heap at that point in time, and you can even drill down. So basically it shows all these classes, how much memory it is taking. You can drill down and get a good view of different objects and how much memory they're using. So that's basically a nice view on the heap dump. Okay, flight recorder, we will use that in a minute. But before that, let's Let's see how much time we have. Still have a few minutes. So let's see the last tool that we have in our list, and that is Visual VM. So Visual VM provides a visual interface for viewing detailed information about Java applications. It connects to local as well as remote applications, provides CPU, memory, threads, and classes usage and their information, but even more. And in terms of feature, it is quite comparable to JMC. So let's take a quick look at Visual VM. Um, and you will see that it is quite comparable. And I think, I mean, so Visual VM was originated at Sun Microsystems, and JMC was originated at BS Systems. But they, in the end, they provide pretty much similar information about Java applications and have similar capabilities. Yeah, and again, we see here the list of applications that are running. We see our application as well, and we get similar information. We get overview, CPU, memory, classes, and threads. And it also provides, yeah, so detailed information about threads, but also a sampler to sample CPU memory and also to profile our application, a profiler as well. And we can do a heap dump or perform GC as well. So again, pretty much similar features. You can even get a JFR recording and do some things. So again, it provides pretty similar feature set as JMC. So for the rest of the talk, I'm just going to use JMC and not use Visual VM. But you get the idea. So we have now looked at different tools briefly. Just to summarize them, so JFR is quite useful and it is quite powerful, provides lots of information with low overhead. J command is quite useful for creating, managing recordings and for other diagnostics. JMC and Visual VM provide similar features, but they are quite feature rich and provide user interface to a visual interface to the data that is accumulated for these different applications. And when we talk about virtual threads, the support for virtual thread is that in JFR we have 4 new events, and in JCommand we have a new format or new way to get thread dump in JSON format. Also, one interesting thing, JFR and JCommand are available as part of JDK, and for JMC and Visual VM, they are externally available, so you can download and use them. Okay, so this is in general about some ways you can monitor Java applications with virtual threads. But at the beginning, we started with a Java application built on Spring Boot, which uses virtual threads, and it had some problems. So let's see if we can solve that problem from whatever we have seen so far. So what we are going to do is we are going to use JMC to get a JFR recording while we open the app and try to reproduce the error that we faced at the beginning. So let me do that. Let me head over to JMC. So this is JMC, and we're going to use this option to create a new file recording, a flight recording, and we're going to use this application and then try to simulate a problem. In this case, we didn't see the problem, but we're going to run it enough times so that we see the problem, and hopefully we see the problem in time for the flight recording. Okay, so how do you get a new flight recording in JMC? Let's double click this. Let's call this recording 001. And event settings. So this is basically the settings XML file. We're going to use profiling, which is by default available. And we'll use that and we'll modify some settings. And we're going to record it for 1 minute. Moving on, I don't think we need to change anything here. So here we're going to enable the virtual thread start and virtual thread end events so that we see them in the JFR recording. Okay, so recording had started and it is recording for 1 minute. So let's see if we can reproduce the error. Yes, so basically we have seen this error now, and because our JFR recording was recording, it should record this problem as well. That's really good. Okay, in fact, we have it once more. It's really nice. Let's see how much time we still have left. Oh, 30 seconds. That's quite a lot of time. Maybe we get it a few more times. So 3 times. So we have actually seen this error now 3 times and 4 times. It's now happening quite frequently. So we have seen this 4 times now. I hope we get to see also a successful, yeah, okay, successful execution is also there. So we get the data sometimes, and sometimes there's an error. So now I think it is working fine. Okay, this is the fourth time that this error has occurred. Probably the time is already up. Yes, it is. We are just in time. So it records the what is it? Creates a recording and it also opens it here. So we see all the things that are present in JFR. So when we use the JFR utility, we saw few things, but here we see all the things that are recorded in the JFR recording. So things about the Java application, threads, memory, file IO, GC related information, some environment related information, and recording itself. So there was only one recording that we created, and uh, the thing that we are interested in, the event browser, and we see that it actually created 68 virtual threads. So we see start and end of these virtual threads, but we also noticed something in the virtual thread pin. So we see it 5 times, and we saw the error 5 times. So probably this uh, could be the reason. We also see that pinning has happened for 5 seconds for each of these calls. And if you notice, if you look at the stack trace for this event, we see that it is happening here. So portfolio controller dot equity. So this is the method that is making the thread go to sleep, and that is what is resulting in the thread getting pinned. Now let's look at our source code to see if we notice something like that. So we have portfolio controller, and it has different methods which basically give us these different values on the screen. And there is this equity bit, which has a synchronized block, and there is a delay that is happening randomly. So this is pretty obvious from here. So if we had looked at the source code, we could have seen this problem. But if it is, let's say, deep somewhere down in your source code, it's difficult to find, and therefore using these monitoring tools really helps us. So what we're going to do here is we're going to first get rid of this thread.sleep, because that is actually serving no purpose. And we are going to replace this synchronized code block with reentrant lock. So let's quickly do that. Let's get a new lock, and let's initialize this lock equals new reentrant lock. And the way to use that is if lock.try lock, we're going to try it for 5 seconds. And if we are able to lock it, then we are going to fetch this data and then return it. We need to add some try catch, and then in the finally block, we are going to release the lock. So lock.unlock. And if it is, if we're not able to lock it, then we're going to just say throw new legal state exception, and then we say error, or we are not able to lock the file. So we're going to just restart our application, and then we'll see that the error is not appearing, or hopefully not appearing. So we have removed the blocking code, and we have also replaced the synchronized with reentrant lock. Our application is started. Now let's go to this application and then run and see that it is no more problem. So we can just call it multiple times, and every time we switch, so there's no problem. Okay, so that's how basically you use monitoring or troubleshooting to fix problems in your application. That is all I wanted to show. If you want to take a look at the source code, it's available in this QR code. And yeah, if you have any questions, you can reach me out here on Twitter, or yeah, and then ask your questions now if there is time left. Not sure if there is time left, but thanks for joining, and thanks for your time and attention, and enjoy the rest of the conference.
There's one question in the chat.
Yes. Let me take a look. Why exactly is there a problem with synchronized block and virtual thread pinning? Why can't the thread scheduler kick out a virtual thread which is blocked waiting state and let others do their work? So that's how virtual threads work. Um, Basically, I think there are some limitations when using synchronized code block or native calls that when a virtual thread gets, let's say, um, unmounted from the platform thread, it might get mounted onto some other platform thread, and that would have issues with its continuation of the execution, and therefore it cannot be simply just kicked out uh, because your application might get in an inconsistent or an unstable state. So that's why it is deliberately pinned to the platform thread, and it just stays pinned. Um, I hope that answers your question. Thank you.